need to create structured data analysis, requests that LLMs can reliably execute with specific parameters. You'll see how FastMCP S at prompt decorator transforms a simple Python function into a reusable parameterized template, complete with custom metadata, type validation, and clear documentation. That ensures consistent LLM interactions every time. At MCP, prompt name equals analyze data request, hash custom prompt name. Description equals creates a request to analyze data with specific parameters, hash custom description. Tags equals analysis, data, hash optional categorization tags. Meta version 1.1 author, data team, hash custom metadata. Def data analysis prompt. Data URI, SDR equals field, description equals the URI of the resource containing the data. Analysis type, SDR equals field, default equals summary, description equals type of analysis. SDR. This docstring is ignored when description is provided. Return F, please perform a analysis type, analysis on the data found at data URI. This demonstrates the prompt has code pattern, where natural language templates are defined as executable Python functions. The decorator approach transforms static prompt strings into parameterized, reusable components that maintain type safety and validation. What makes this distinctive is how it bridges the gap between structured programming and unstructured language model interactions. The pattern works by treating prompts as first-class citizens in your codebase, with the decorator handling registration, schema generation, and type coercion automatically. Your function defines the template logic and parameters, while the framework manages the conversion between Python types and the string-based MCP protocol. This separation lets you focus on prompt design rather than transport mechanics or validation boilerplate. This approach matters because it solves the prompt management problem at scale, where hard-coded strings become unmaintainable across multiple LLM integrations. By defining prompts as versioned, typed functions, you gain IDE support, validation, and discoverability while keeping your templates synchronized across all clients. The trade-off is a slight learning curve for the decorator syntax, but the payoff comes in reduced prompt drift and easier collaboration between prompt engineers and backend developers. Let's break it down line by line. At MCP, prompt name equals analyze data request, hash custom prompt name. This defines a custom prompt name for AI model interaction. The name analyze data request uniquely identifies this prompt template, enabling precise selection when triggering analysis workflows. Description equals creates a request to analyze data with specific parameters, hash custom description. This description defines the prompt's purpose for AI models. It appears in tool documentation and helps the model understand when to use this specific function, distinguishing it from similar analysis tools. Tags equals analysis, data, hash optional categorization tags. Optional categorization tags for tool discovery. These metadata tags help AI models and tool registries group related functions, improving searchability when multiple tools exist. Follows the same pattern as FastAPI's operation tags for API organization. Meta version 1.1 author, data team, hash custom metadata. The meta parameter attaches custom metadata to the prompt definition. This enables version tracking and team attribution, critical for maintaining prompt registries in production systems. FastMCP surfaces this metadata in tool discovery and logging interfaces. This closing parenthesis terminates the @MCP prompt decorator's configuration block. It finalizes all metadata, parameters, and type hints before the actual function definition begins, ensuring the decorator has complete information to generate the tool schema. Def Data Analysis Prompt. This defines the core function that implements the AI callable tool. The decorator above transforms this into a structured prompt template, while the function body generates the actual request string from parameters. Data URI. SDR equals field. Description equals the URI of the resource containing the data. This defines a required string parameter using FastMCP's field class, which enforces type safety and provides metadata for AI tool schemas. The description becomes part of the tool's documentation and input validation, ensuring callers provide a valid data URI. This pattern is standard for all FastMCP tool parameters to maintain consistent interfaces. Analysis type. SDR equals field. Default equals summary. Description equals type of analysis. This defines a parameter with a default value and metadata. The field class sets summary as the default analysis type while providing a description for AI tool documentation, ensuring the prompt remains flexible yet well documented. This pattern is common in schema-based systems where parameters need both runtime defaults and clear documentation. SDR. This is the return type annotation. It declares this function returns a string, enabling static type checking and IDE support. FastMCP uses this to validate the tool's output schema before execution. This docstring is ignored when description is provided. This docstring is intentionally ignored when the @MCP prompt, decorators, description, parameter is set. FastMCP prioritizes the decorator's metadata over the function docstring, so this serves as documentation for developers while keeping the AI-facing description clean and controlled. Return F, please perform a analysis type. Analysis on the data found at data URI. This constructs the natural language request that gets sent to the AI model. The F string dynamically inserts the user-provided parameters into a standardized instruction format, ensuring consistent AI interaction while maintaining flexibility for different analysis types and data sources. This is the core pattern for converting structured function inputs into AI-compatible prompts. FastMCP prompt engineering. The @MCP prompt decorator transforms Python functions into structured AI requests, where metadata and type hints become the contract between code and model. Default values and function signatures define optional parameters, but missing field descriptions will leave clients guessing at the schema. Every prompt is both a function and a message template, merging execution logic with natural language generation.
The prompt that describes itself needs no description.